Okay, so I'm going to talk about some work we've done to try to make it easier to answer this question. Oh, no, it's not. It's not me. No, yeah, I should.
What is the evidence of the statement that's not
Yeah, I went over the trials, and for once it was really small and pretty average. But yeah, the day I left from Tahiti going home before the main contest started, apparently it's the day the score popped up on the map.
I was there for a few weeks before it. I got there for a year.
I think this is more interesting. Right. That's right. That's very interesting. I want to find out what that was. So I think this is basically a question that was asked at the dawn of the scientific revolution, the 17th century and before, right? Because people were making statements about the truth of the world based on literature and deduction from statements in the Bible, Aristotle, and all the rest of that, and changing the way that we think about what is evidence was absolutely basic to science. Right? We think of evidence very differently now. So here are some things I want to talk about, and I'll try to get them into 10 minutes, and stop me when you're ready. There are some serious problems in the literature today, I think, that have been identified of problems in reproducibility and what's called citation distortion, bad citations of various kinds. And we believe, and we've been working on this problem for a few years, quite a few years, that they're addressable by means of direct citation of data and methods, claim graphs resolvable to direct evidence, and software tools to support this. So, reproducibility problems. Someone yesterday mentioned the Begley and Ellis paper in Nature this last year. They found that only 11% of the academic research that they took into Amgen, which is where they work in the hematology-oncology group in Amgen. Only 11% was reproducible for a number of reasons that they tried to identify. For example, and this is their samples that 53 landmark papers. Obviously, this is what people try to do in industry. They say we're working in a certain area. Let's get all the landmark papers and let's reproduce it. I have colleagues of mine that collaborate with Novartis. Novartis did the same thing. Bayer does the same thing, and they all get kind of similar results. I heard this kind of 10 to 12% number anecdotally from a colleague in the institute that I work in several years ago, actually, based on his experience working with Novartis. So this is what Begley and Ellis said. Scientific community assumes and my colleague Steve Greenberg at Children's Hospital in Boston, who studies inclusion body myositis. It's a degenerative muscle disorder. Published this paper. He's also an implementation. He published this paper in 2009. And here's an example of, he basically took this statement, amyloid beta accumulation causes inclusion body myositis, a little bit more nuanced than that, but it would take up too much space. He had a student of his analyze, make a claim network through 242 papers. It turns out, they all accepted the statement, including review articles in Lancet Neurology, and found that there was primary data supporting this in only 4 papers. They were all the same lab, and there were reagent specificity problems. Okay? So, if all of our models are based upon experimental data, and we don't really know whether the publications are crap or not, then maybe we've got a problem. So let's ask ourselves, what is scientific evidence? And we sort of have a formal definition. It's a provenance set of data supported by a provenance set of reproducible methods, right? With a clear narrative of how the methods were applied to obtain and compute the data, and sufficient description of the methods to reproduce and reuse them, right? So this means that we have to have citation of both data and methods in the papers in a way that they can be obtained. People treat data in scientific publications many times as a second-class object. That is, I will generate primary data, and I will do some analysis on it, and I'll publish the graphs. Okay? And that's, here's figure 1. See figure 1, it indicates the following, right? If you're very interested, the data is available from my lab at this website, blah, 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 and the website may not be up forever, may not be up for a very long time. It might be hard to obtain the data, right? So what we're saying is data has to be a first-class object. There are a number of international groups working on the problem of data citation. The recommendation is data has to be cited as you cite a publication. So I would say we found that, here's the graph, we found the following. Here's a little number 5 in brackets, or whatever you use for a reference mark. And number 5 is in the reference list, and it lists the authors of the data set and a DOI to retrieve it. Robust archive to support this, to support these criteria. There are a number of these coming now. Dryad, Dataverse, Dataverse is at Harvard. My colleague Mercedes Croesus is responsible for that. Dataflow at Oxford. Method citation. This is something that Marianne is working on a lot, and we collaborate with her on this. Methods are more reusable than data. People talk about data reproducibility, but really, if you can exactly 3 minutes of what? Okay. So, methods are more reusable than data, actually. If you reproduce data exactly from experiment to experiment, there's something wrong. What you really want to be able to do is reproduce the method so you can generate some sufficiently similar set of data that you're statistically confident that these methods are working. Right? Core methods should be cited in the table of methods or in the references section. Marianne and other colleagues are working on this. And core need here is method registries, right? And publisher support for this. So, for example, and Marianne will tell you about this, they have a beautiful registry in the Neuroscience Information Framework of over 1 million antibodies commercially available. It resolves across these suppliers and so forth. And what we want to be able to do is cite in the paper these antibodies or any methods or materials that are largely responsible for variability in the experiments. directly or indirectly, you need to have a resolvable chain of references, and that needs to actually be machine resolvable. And if you can do this, then you can create claim networks that are computationally resolvable to evidence and are very useful. So this overly rapid animation shows a claim network that we derive from some of Steve Greenberg's supplemental data, where there's a scientific argument up at the upper left. It cites the claim. The claim is resolvable through a number of papers back to a scientific argument that cites, that provides absolutely no data to back up its statement, right? It's mere speculation, but over time, there's sort of a natural selection applied to scientific claims to remove qualifiers, right? So publication of the most striking results is selected for, right? So highly ambiguous results, including mere speculation, are not as publishable as strong results, right? So we'd really like to know, what was the method that you used? Can I reproduce it? Where can I get the reagents, the software, the models, and if there's actually any data behind it ultimately. So what do we need to do this? We need registry and repository support, publisher and NIH support, and software tools. So one of the things that we do for software tools support, one of the things that's important is to be able to make claim networks. And there are ways of doing this. We pioneered one of them called the Swan Discourse Ontology. People in the OpenText collaboration, which we are part of, working on something called nanopublications. We have a model called micropublications, which generalizes across these. And it's based on the notion that all publications are an argument, essentially, and they're in linear form. But you can also, because of the sort of requirements of scientific publication, you can also define a formal structure over this linear structure, and you can apply it as annotation, and the annotation can be stored separately. And we have a toolkit to do this that can store the annotation, re-inject it into the publications, and we call this micropublications. Micropublications can be layered, so you can represent all kinds of abstractions on scientific claims, including annotations, comments, discussion threads, formal representations, and you can layer them all the way back to the originating data. So I actually want to thank a number of people for financial support of this toolkit, including Elsevier and the NIH and Eli Lilly and Company and Amazon. So version 2 alpha is with support for micropublications will be out in the next month. This is open source software. It's designed for modularity and extensibility. So we welcome collaborators who want to work on specific plugins for this. Very, very interested in anybody that wants to look at this code, sign up for an alpha, or participate in the development. So in summary, so we have problems in the literature. People talk about data deluge, but actually there's a publication deluge, and there are quality problems in this publication deluge. We want to cite the evidence. We want to cite data and methods as first-class objects. We want concrete backing for the claims, and we want to implement this via claim networks, and our solution to this is